Permutations. A teacher has 5 books and wants to display 3 of them side by side on her desk. How many arrangements of 3 books are possible? If you're counting arrangements or assignments, that's a permutation. So we have the 3 positions for the 3 books. So you're going to make the assignment for the first position. There's 5 books that can take this position. But once you assign the book to this position, there's only 4 books left for the second position. And once you make assignments for the first 2 books, there's only 3 books left to assign to this position. Multiply them, you get 60 possible arrangements. In a college admissions forum, 5 female and 4 male sophomore panelists discuss their college experiences with high school seniors. A, in how many ways can the panelists be seated in a row of 9 chairs? So here are the 9 chairs. So the first chair assignment can be given to any of the 9. But once one of those 9 takes that chair, there's only 8 people to assign the next position to. But once someone takes this chair, there's only 7 people to assign the next position to down the line until you only have 1 person left and 1 chair left. You multiply it and you get your answer. You could have gotten the answer by doing it this way. Notice this is a multiplication principle, and when the numbers are not repeating and they're declining one by one, then you could call it a permutation. Another way of saying that is the multiplication principle with no repetition is a permutation. So permutations count assignments without repetition. Without repetition means that a person cannot be seated in 2 different places. So this is a multiplication principle with no repetition. Or you could say a permutation of 9 objects taken 9 at a time. The answer is 362,880. B, in how many ways can the panelists be seated if the males and females are to be alternated? So notice alternated means that female, male, female, male, they alternate. There are 5 females and 4 males. So they should be 1, 2, 3, 4, 5 females, 1, 2, 3, 4 males. So concentrate only on the females first. So this female, there's 5 that we could choose to assign this chair to. The next female chair, there's only 4 females to assign this chair to. Go to the next female, there's only 3, and down the line. Now go with the males. For this first male, there's 4 males available to assign this chair to. Go to the next male position. There's only 3 males that you could choose to assign this position, and down the line. Multiply these numbers, and you get 2,880 ways that the panelists can be seated if males and females are to be alternated. C, in how many ways can the panelists be seated if the males must sit together and the females sit together? So there's 2 ways you could do that. You could have the females first and then the males, or you could have the males first and then the females. Or, remember, can translate into plus. And if you look at this, these are replicas of each other. So you're adding the same thing, so it's 2 times the same thing. So here is the females. That's 5 factorial. Remember, a factorial is, 5 factorial would be 5 times 4 times 3 times 2 times 1. And this is 4 factorial, 4 times 3 times 2 times 1. So that's this, the symbol for that. And this one, here are the males, so it's 4 factorial. Here are the females, it's 5, so 5 factorial. So you multiply this, and add them, or since these are the same, just say one of these times 2. And you get 5,760 ways the panels can be seated if the males must sit together and the females sit together.